We shall continue our discussion.
Good morning.
Yeah, good morning. Let me share the screen. Our entire screen. This is our syllabus. So we are here. We are introducing probability. This is a problem we had seen in the previous class. Do you see the screen? Someone speak.
Yes, sir.
Great. And
Yes, sir.
you people should speak voluntarily. Okay. Instead of me to mention the names or inviting your attention, you people should be ready to speak without me asking you to speak. Let us consider one more problem. Another problem. Suppose if I have 8 positive numbers and 6 negative numbers we are having. Okay. You can write. Let us have 8 positive numbers and 6 negative numbers. We choose 4 numbers. I'm not mentioning what kind of numbers they are. 4 numbers randomly without replacement, meaning we can choose one by one also, or we can choose simultaneously. That's what we mean by without replacement, meaning 4 numbers we choose 4 numbers randomly, we multiply them. We multiply these 4 numbers, or instead of that, we say 4 numbers are chosen randomly without replacement and multiplied. And we multiply the 4 numbers. The question is, what is the probability that the result is positive? If I say them, it means these 4 numbers. That's why we wanted to write in another way. Let us have 8 positive numbers and 6 negative numbers. 4 numbers are chosen. Yeah, do you understand the question? 4 numbers are chosen at random. We are multiplying them. What is the probability that the result is positive? Think about it.
Sir, 8C4 plus 6C4 plus 8C2 into 6C2 by 14C2. 14C4.
Let us Others, is there anyone disagree with this result? Or any other result they have? Anything is fine. Any other option? So we want to choose 4 numbers. First is trying what is the total number of possibilities. We are having 8 and 6, 14 numbers. After that, we want to choose 4 numbers. Denominator is fine. If you need positive, you have all the 4 positive. this can happen, or all the 4 negative, or what else you can have? 2 positive and 2 negative. Oh, I should write and here. 2 positive and 2 negative. You can have. These are the 3 cases. Instead of this R symbol, you are writing this plus. Oh, sorry. This is how, this is whatever I have written in red color is rough work. All 4 chosen numbers can be positive. In that case, the result is also positive. All the 4 numbers can be negative. Meaning 6 negative numbers, you can choose 4 from there. And sometimes you can have 2 positive numbers, 2 negative numbers. If you multiply these 4 numbers, these encircled things are referring the 4 numbers, the possibilities we need for getting a positive result. So instead of this and, so this is what they are having. The third case or the second case or the first case. Simplify and get the number. Are you following this? What are the rules we have used here? What are the rules we have used here?
Sum rule, product rule.
Sum rule and product rule, both we have used. This is not shown. This R becomes addition, this R becomes addition, this and becomes multiplication. That's okay. This is some basic probability problem. Just we are willing to review because yesterday also we had a similar problem. The paragraph may be lengthy, but the idea is demanding only these 2 rules as of now. Now we shall go for the further topics. This is just a review about probability. Maybe I shall send you few more practice problems that you can practice. And if you have any difficulty, as usual, you can contact me at any time. Now, we shall talk about random variables. Any of you heard this term, random variables? Quick, yes or no? You don't worry about others, you reply your own answer. Do you know the term random variable already or not? 56 people, all the students, those who are 56 people can answer this question. Do you know that or not? Have you ever heard the term random variable? Say yes or no.
Yes.
Is there any yes? Okay. Let us introduce that now. When you have an experiment, you can write down the sample space. Okay. Even we already discussed. Consider our BTech students. There are 240 students, I hope. Say, let us assume 240 students are there. Meaning 240 roll numbers I can write in a set notation. Now, I can categorize these students. How do I categorize? I want to make partition like set theory, meaning I want to split this into 3-4 groups. So I can split into computer science students, EC students, EEE students, mechanical, civil. So 5 categories I have created now. The actual thing was set of BTech students in our campus that I am splitting into. These are the computer science students. These are the, this kind of category also I can do. Then for these students, computer science students, say suppose if you assume that computer science students are 90% placed. Mechanical students are 87% placed. Civil students are 86% placed. Placements I am talking about. Then each group is having a probability. Each category is having a probability. We can write down that on a table. Suppose if training and placement officer is presenting, so far achievements, he will be presenting something like this. Say ECE students, 87%. CSE students, 90%, something like this. So this is a probability. This 87% is actually 0.87, 0.90. Instead of this, we will write that. This table I will be presenting. This is the category or variable. The similar situation we would like to consider. Okay. So what we need is we need the random experiment and the sample space. We shall start with an example. First, just maybe you may go through these slides. So let me write down random variables. This is what we want to discuss now. First, let us look at an example. Let us look at an experiment instead of example. Let us look at an let us look at a random experiment. Then we shall come back to define, apply, utilize these random variables, what they are. Before that, now I tell you the random experiment. Suppose if you are suppose if you are sitting in our canteen and you are simply making a record. How many boys and girls come to the canteen? Okay, only first 4 people you are recording. You are simply sitting in our canteen and taking a notebook and you are recording. Out of the first 4 entries into the canteen, how many boys are there, how many girls are there? Now I am asking you, what are the possibilities? Can somebody tell me one possibility? One example possible record. Quick. 4 entries you are going to record.
2 boys, 2 girls.
How do you say that? Actually, 2 boys, 2 girls. Whether this you are talking about or this.
First one, sir.
So you will be saying first boy, second boy, third girl, fourth girl. These 2 things are different. This also can happen. Okay. Sometimes all the first 4 people may be girls. We don't know. Okay. Now I want to list all the possibilities. How many possibilities are there? Total number of possibilities. So you should think about kind of this. You want to make 4 entries. This may be boy or girl. 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 Are you understanding this? So what is the total number of possibilities? Someone has typed, I think. You should speak. 2 power 4. What does it mean by 2 power 4?
2 power 4 possibilities.
Okay. You are talking about boy or girl. 1 plus 1. And here boy or girl. 1 plus 1. And okay. 2 power 4 is 16 possibilities you are talking about. Okay. Maybe. Let me write them down. So some pattern I should follow. Maybe I am writing all girls. This is one possibility. 3 girls, 1 boy. This is another possibility. But the boy is in 4th place. Sometimes in the same category, I can have first girl, Then boy, the remaining two are girls. Just I'm sitting there. People during some time break they make entry to the canteen. Just I am saying after completion of my experiment, I can have any of these possibility. And sometimes, as you suggested, it may be two girls, two boys situation. Okay. This is also two girls, two boys. Are you understanding these possibilities? What else can be there? BB, GG. What else is there? GB, GB. Is there any other possibility? Boy, girl, boy, girl. Is there any other possibility with two boys and two girls? Boy can be here, then girl, again boy. Is there any other possibility for two boys and two girls? Hmm. How many have written? We have written 1, 2, 3, 5, 7, 11. 11 we have written. Remaining 5 we should write. Possibilities. Total 16 possibilities I know. Based on sum rule and product rule. Then, can somebody suggest what will be the other possibilities? Remaining 5 is missed already. Pick.
3 boys, 1 girl.
3 boys, 1 girl. Okay, good. 3 boys, 1 girl. As usual, this girl may be making her entry on third place, or this can also happen. Our first girl, the remaining entries are boys. And the last entry is easy, I think, all boys. These are the 16 possible outcomes in our experiment. The experiment is recording in our canteen whether it is a boy or girl. Now, the 16 possibilities are categorized in terms of number of boys or number of girls. Now, let me define x equal to capital X equal to number of girls. Something like this I am defining. Maybe I am defining number of boys. It doesn't matter what thing I am using. In this way, I want this capital X. Okay, suppose if I define like this, then what happens? If I define like this, this is my choice, whatever I have written red color. Now, for this category, X is becoming 0. Look at this. Number of boys is 0 in this category. For these 4 outcomes, X equal to how many boys are there? 1 boy. Here 2 boys. Here 3 boys. Here 4 boys. Now, it's like 5 departments I have categorized, and each category is given a number based on this definition. Suppose if you choose X equal to number of girls, then capital X equal to 4, capital X equal to 3, 2, 1, 0. What you do is, when you consider a random experiment and when you consider the sample space, for each element in the sample space, you are giving a number. What is a number for this sample space element? Immediately you will go to this definition. The number is based on number of boys. So immediately you will be writing X equal to 2. Do you see that? Suppose if you choose this sample space element, you will go to that definition. Okay. then you will find out this number. Do you see that? The idea is to each blue color outcome of our experiment, we are assigning a number. Now, one more thing. What is the number for this outcome? This one. What is the number for that outcome? Somebody tell me quickly.
X equal to
X equal to 2. What is the number for this? Quick. So you have to go to the definition. We have already written here. X equal to 1. The number of boys equal to 1. If you change the definitions, the numbers also will change. But we are interested in the random experiment. When we have the sample space, to each element in the sample space, we are giving a number. To each student, we assign the department during admission. To each student, we assign the department. Similarly, here to each outcome, we are giving a number. This kind of assigning numbers is called as random variable. Here the 0, 1, 2, 3, 4 are the random variable values. Random variable is a value which depends on a chance. Or simply random variable is a variable whose value is depending on a chance. We have no control over x equal to 3 or 4. Simply we define, then we get these values. Or in other words, we can say random variable is a function from the sample space. Functions we discussed already. So the definition if you need, random variable is a function from sample space, meaning for each element in the sample space, we can talk about the value. Think about this for a minute. If you have any question, you ask me now. Based on this, we will proceed further. For each category, we are giving a number. That's it. Two definitions I give you. Random variable is a variable whose value is depending on a chance. Another definition, random variable is a function from the sample space to real numbers. You can write simply like this. Random variable, two definitions. Maybe let me write down. Definition 1, random variable is a variable whose value depends on a chance. That's it. So whether you are going to get x equal to 4 or x equal to 3, that we don't know. Simply we will be sitting in canteen. Only based on the chance, based on the happenings, then only we will realize what is the value, whose value depends on chance. Or in another word, it is random variable is a function from sample space. Function from sample space to real numbers. We are going to assign. Usually it is positive numbers. So I will be writing x is from here to there. Look at our example. This is has 16 elements. To each element, we are going to give numbers. For each element, we are going to give numbers. And also we can talk about one other thing. Maybe we will copy this again. We can talk about see. Now I'll ask you, what is the probability for 0 buys? I am asking you this question. What is the probability bar for 0 buys? What is the probability? Look at the blue color thing. There are 16 possibilities. Out of that, only one possibility is favorable to 0 buys. Do you see that? What is the probability for 1 buy? Out of the 16 possibilities, how many are possible? Favorable to 1 buy? 4. You see that? I can talk about the probability also. What is the probability for 2 buys? Somebody tell me quickly. For probability of 2 buys out of 16. Quick.
6 by 16.
6 upon 6, 16. The remaining thing I will be writing directly. For these probabilities, only 4 favorable cases out of the 16 total number of cases. So again 4 divided by 16. For this, what it is? It is 1 upon 16 possibilities. Once you have random experiment, you can define random variable. Based on that definition, you can talk about probability. Suppose if I look at this last sentence, I will be writing here. Usually I will be writing capital X equal to small x. Capital X is the random variable. Small x is the value taken by the random variable. Okay. I can talk about this capital X is taking these values. It is not suffix and all. It is capital X is taking these values. What is the probability for that random variable is taking this value? Capital X can be 0 buys, 1 buy, 2 buys, 3 buys, or 4 buys. I don't know. Okay. What is the probability for 0 buy? It is 1 upon 16. This is 4 upon 16. 6 upon 16. This is 4 divided by 16. This is 1 divided by 16. This is what um, we have written above. That I am rewriting here. If you are able to write down like this is called as probability distribution. This is called as probability distribution. The question is the situation we are having is experiment. Okay. Recording first 4 entries. Entering canteen. recording gender. Okay, recording it is our experiment, so we are going to define proper recording gender for first 4 persons entering canteen. Okay, and also I should define what is my capital X. Just I want a number of boys. All these experiment we have done already. Okay, all these experiment we have done already. Just the question is let X equal to number of boys. I'm asking you write down the probability distribution. If you write this table, that is called probability distribution. This will give you information about each category possibility. And look at the sum of the probabilities. What is the sum of the probability? Quick, somebody compute and tell me. If you add all these probabilities, what do you get?
1.
You will be getting 1. Okay. Okay. Now we will. Is there any other thing we want to realize from here? We can draw the picture for this. We can draw the picture. Maybe in the next slide we will draw that. Okay. The same thing whatever we have written here. Just we want to note. Probability distribution we have already written. Same thing we can draw like a picture. So this is a 0, 1, 2, 3, 4. Okay. These values we want to draw. We want to mark somewhere here. Near 0 it is this number, say 1 upon 16. And for 4 also the same number. Sorry. So we want to mark 1 by 16 here. For 4 also it is 1 by 16. For 1 it is 4 by 16. For 3 also it is 4 by 16. For 2 it is 6 by 16. This is 6 by 16, 4 by 16, 1 by 16. You can draw this picture. This is also one way of representing probability distribution. Now let me define what is probability. It is the table of probabilities. Or in other words, this random variable is having a probability rule. That is called a probability distribution. Look at this is probability rule. Even though we don't explicitly mention, whenever you have 0, probability is 1 by 13. Whenever we have the random variable value 1, probability is 4 by 16. This rule is called as probability distribution. And we can The same thing we can try in other presentation also. The same thing, right? Maybe I'll give you this rule. Okay, instead of this, I can write the probability. Just this is what I need. This is just as a specific example, so I'm explaining based on that. Later we will write in terms of theory. I want a probability for this value. The small x can be 0, 1, 2, 3, 4. For that, instead of this, I shall write a function. That function I will be writing like a table. This kind of functions have you seen? The probability is 1 by 16 if x equal to 0 or 4. This probability is 4 by 16 if x equal to, I am writing from the table. You see that? 1 or 3. Otherwise, it is 6 by 16 if x equal to, what is it, x value? 2. Otherwise, what do I write? Suppose if x equal to 7, what is the probability? Somebody tell me. If x equal to 7, what is the probability? Quick.
0.
0. That's it, exactly. Okay. These are the 3 ways of writing the probability rule from that experiment. Probability rule for the random variable. There are 3 ways of representing the probability rule for the random variable. And instead of this probability of x equal to x, usually we write f of x, with understanding that f of x equal to probability of x equal to x. You can use synonymously any of these. You can write like this, where this f of x is actually a probability for this value. That's it. 3 ways of representing. One more example we will see. Hereafter, any one of these is enough. Any one of these 3 representations. Which one we prefer? Which one you like? Tell me, someone, quickly. Which one will be more appropriate? Which one you like to use hereafter? Which is easy? That's what I'm asking you. Among these 3 representation, if I give you some experiment, if I ask you probability distribution, among these 3 type of representation, which is easy for you? Quick.
F of x.
This last one. Okay. Actually, for me, this table is easy, but table will be difficult. Suppose if my random variable takes 100 values. So then I have to write a table with 100 entries. Instead of that, I will be writing this kind of function in general. One more example, maybe we will try another example. Okay, here I am not writing down the definition, repeating things from the textbook. You should read from the book also for the formal definition and all. We are explaining now. I'll give you one experiment. You comment about the probability distribution. I am tossing 4 coins. They may be head or tail. Okay, 4 coins I am tossing. I want to record the number of heads. Okay, my experiment is toss 4 coins, and my random variable is defined as number of heads. I am asking you find probability distribution. Can you do this? Can you take this as homework?
Yes, sir.
Or can you do it now on spot? Any of you?
So same like previous question.
There is no difference between the previous question and this present question except the names. Here you will be having, instead of boy girl, you will be having head tail. Okay, the same thing you will be having. One more experiment we will do. Experiment. Toss. Coin only we use toss. Throw 2 dice together. Okay, this is our experiment. Capital X is sum of the values shown in dice. Okay, suppose if I am throwing a pair of dice, suppose if I am getting 3 in the first die, 4 in the second die, then I am having 7. 3 plus 4. Now the question is find the probability distribution. For this table is okay, even if you don't write this function or if you don't draw the picture. Okay, can somebody comment on this? Maybe I'll ask you how many number of values capital X can take. That's my first question.
From
How
2
many?
to 12.
2 to 12. So then I should write 2 to 12 you are saying. Okay, because we are willing to do the summation. Okay, very good. Let me write down here this capital X can take these values. It will be 2, 3, 4, 5. These are the values taken by the what are the total possibilities for this experiment? Total number of possibilities.
36.
There are 36 pair of values you can have. So what is the possibility favorable case for getting the summation is 2?
1 by
Maybe,
36.
maybe if you are not familiar, I will be writing like this. 1 and 1 I can have. 1 and 2 I can have. 1 and 3 I can have. 1 and 4. 1 and 5. 1 and 6. These are the sample space elements I am writing. To 1. In this way, 36 possible outcomes I can obtain. Okay, the pen is not up to the mark. Usually I'll be splitting these things by a comma. First outcome, second outcome, third, fourth, fifth, sixth, seventh, eighth, something like this. Okay. Finally, I'll be having 6-1, 6-2, 6-3. Yeah, these are the 36 possibilities. Now, among these, only this first entry will give you summation 2. So the probability for that particular value is out of 36, only one possibility is favorable to get the summation 2. What about this summation 3?
2 by 36.
2 by 36. Summation 4, 3 by 36. Summation 5, 4 by 36. You think about this, okay? What about summation 7?
6 by 36.
Summation 8? This is it. Okay. This is the required table. Maybe just we shall write these horizontal lines here. Probability distribution table. You can draw the picture or you can write down this functional definition, function definition, anything is okay. But this also is fine. With this, we shall stop today. You try some other examples. We shall meet in another class. Do you have any doubts? We shall meet in another time. Okay.
Thank you, sir.
Thank you all.
Thank you, sir.
So I shall
Thank you,
share
sir.
this PDF as usual. You people should refer that. Okay, bye.